Welcome back to Softwaring. I'm Lordman. Today I'm going to go over on the beam design optimization by using ansys workbench. So as you know the drill, the designing of a beam is somewhat straightforward procedure. So depending on the cross section of the beam, there are different different approaches of designing or filtering the beam geometry or parameters. So in this particular video, the cross section is a rectangular cross section with a base of 140 millimeter and the height of 30 millimeter, and also the length of the beam is 200 millimeter. So it's simple as a cantilevered beam, and that the one end is fixed and the other 2000 Newton force is applied. So in the initial design we can get this 30 by 40 millimeter cross section by rough manual calculation. So in this optimization analysis, what we have to do is we just optimized the design for different base and height. That means for different cross-sectional area of the beam, and also we can get the base and height for a specific factor of safety. So as per your interest, you can select the geometry or the base and height from your optimized design, or you can even target your factor of safety, and you can get the required geometries for the target factor of safety. So in this video I'm gonna show you how can you do this optimization analysis step by step. Keep watching. I back after a break, and this is the usual the usual workbench graphic window interface. So as you see from here, from the analysis setting, there are different things are here. So such analysis can be performed or can be initiated by using static structural. So open by dragging the static structural to this standalone system, to create standalone system. And then as you see from here, there are different 4 steps we can do step by step. So let us take our engineering data or the material of the beam first. This is structural steel, which is a default material for ansys workbench. It is Young's modulus and Poisson ratio are here. This is a custom material. So let us take it as it is. You can change your material by your own. If you want to analyze another material, you can change here. So let us proceed to the project. Let us start our geometry here on the design modular. I think it is straightforward. We do a lot of things on the design modular. So let us adjust our unit here, and let us select one plane and start our sketch. Let us create the cross section first, a rectangular cross section, and let us dimension it as usual. The base is 40 millimeter and the height is 30 millimeter. Once we give the dimension, let us parameterize this height and base. So let us parameterize the height. This is the base, and this is the height. This is the height. And then let us extrude this cross section. Let us select the sketch here, and the extrusion depth is gonna be the length of the beam, 200 millimeter. So let us generate it as usual. This is our beam. which initially we designed by manual. So let us close this design module and proceed to the next step, which is model. So let us refresh the model stage. The ANSYS mechanical interface is open, so I think you are in intermediate level. So here is the geometry, the solid. Let us rename this beam, and also the material is structural steel. We just take it our material, and from meshing let us change element size as 5 millimeter, and then let us generate this. So this is a discretized beam with 5 millimeter element size, and also let us apply the boundary condition like fixed support and the load. Let us select this face, and let us apply the force. This force is defined by components in the minus y direction 200 Newton, and from the solution stage we can extract results like the total deformation, the von Mises stress, and the factor of safety. Let us insert fatigue tool. From fatigue tool, let us insert the factor of safety factor. So let us solve this. So as you see from the solution stage, the total deformation will be maximum at the point where the load is applied. So the magnitude of the maximum deformation is 0.299 millimeter, and the total equivalent stress will be maximum at the fixed support. And the safety factor will be maximum at somewhere, and the minimum safety factor gonna be 1.082. So this is the minimum factor of safety. So let us parameterize this minimum factor of safety, and then let us close this window and proceed to the next step. From the toolbox, let us drag the response surface to this project schematic. Let us open the design of experiments, and for the two input parameters, the base and height, there are different iterative dimensions. So for the base, let us take the lower bound is 25 millimeter and the upper bound as a 45 millimeter, and also for the height, the lower bound as 25, and also for the upper bound will be 35 millimeter. So as per your interest, you can maximize the interval of your iteration, and also let us update this one. It takes somewhat a few minutes. An iterative design is completed. In fact, we don't know what's going on in the black box. So as you see from the outline of schematic P2 or design of experiments, there are two input parameters like parameter 1 base and parametric 2 height. So as you see from here, the property of height line, the base is iterated between the lower and upper bound 35 and 45 millimeter. Similarly, the height is iterated between 25 and 35 millimeter lower and upper bound respectively. So after the iterative design is completed, we can see different factor of safety for the parameter 1 base and parameter 2 height within the lower and upper bound. So as per your interest, you can select any of the design point here based on factor of safety. So if you want to some secure design, you should select the factor of safety much greater than 1. Always any component which is designed with factor of safety less than 1 will fail. So as per your interest, you can select your design point at specific factor of safety. In this case 1.5 for the last the ninth design point is somewhat secure, and the remaining somewhat less secure when compared to this one. And also let us proceed to the next. Let us update this response surface. So let us update this one. So from this response surface we can observe the response points. So let us change the mode into 3 dimension. So this is how the base and height, or the parameter 1 and parameter 2 can be interrelated with the factor of safety. So for larger height and base, it will have somewhat larger factor of safety. So this is the response chart for parametric 3 or safety factor minimum. And also let us proceed to the next step, which is from the toolbox here, let us drag the response surface optimization to the response surface here. All the parameter and the response surface are transferred to this response surface optimization. So let us update the optimization only. So from this outline schematic of optimization, objectives and constraints are here. So from optimization tool, let us parameterize our minimum safety factor, and objective type, let us seek target. That means we want a specific target. So our target gonna be 1.5 safety factor minimum. So let us update this one. Once everything is completed, we can get the candidate pointers for this target factor of safety. So here are 3 candidate pointers. As you see from here, the parametric value is 1.5, 1.4998 and 1.4998 similarly. So the variation from the reference, that means the variation with the targeted factor of safety is gonna be 0%, and the remaining 2 is 0.01%. So based on this variation from the reference, we can select candidate point 1 as a better design for the target factor of safety. And you can do, or you can observe other results by using this optimization tool. So I hope this will get you something in the optimization of beam design. And in the next video I come back with another qualified and good presentation. So for the time now, thanks for watching. If you have any idea, comment, suggestion, anything related to this video, put on the comment box below. Thanks for watching.